Today, Algebra 3, it is calculating standard deviation, and in your first example set, there's just a few things to go through. First, for standard deviation, this is all based on a normal curve. A normal curve looks like this, and it's sectioned off into standard deviations of 1, 2, 3, 0, which is the same as the mean, and then -1, -2, -3. You can have more standard deviations, but usually in a normal curve you have from -3 up to +3. Inside the curve, things you should remember are that the middle two columns there will add up to give you 30 or 68%. 68% of your data will fall in between -1 and +1 standard deviations. And then if you add in the green with the two bars on either side, that's 95% of your data that will fall in that area. And then if you add in the outside bars with everything else, it's going to be 99.7% of your data will fall in there. Of course, there's still these left over out there, and if 99.7% falls between -3 and 3, then you have 0.3% left over on the outside. Since you have two of those out there, 0.3% divided by 2 is what? 0.15. So each of those tails would have 0.15 in a normal curve. The formula for standard deviation, you have two of them. You must know both. And we'll go over each here in a little bit, so you don't have to write them down yet. The formula for population is different from the formula for a sample. And the bottom is the difference. On population, you're dividing by n. On a sample, you're dividing by n minus 1. Also, another difference is the average is expressed as mu, a Greek letter mu, in population, and x bar in sample. The difference between a sample and a population is this. The population is the entire rectangle. The sample is just a piece of the population. So in this case, you would divide by n minus 1. In the population case, you divide by n.